welcome you all again another webinar that is the network security and today's we'll try to cover security fundamental and ACL details. So before I start our today's session, so let me introduce first. This is Nazrul Islam. I'm working as a network manager in a private company of Bangladesh. Actually, it's a cloud provider in Bangladesh. So it's a short overview of mine, and let's start our lesson. So before starting our lesson, first there is lots of things we have to cover. So it's related to the security. So before jumping into that part, I just revert you all your and the basic things. What is the layer 2 and layer 3 things? Actually, it's about layer 2 and layer 2 how it actually works. So and in layer 2 for covering the layer 2 and layer 3 technology, we just chose a two device that will be better for us to understand how actually it works. So we'll just for example we take a switch like layer 2 and layer 3. If we understand how actually layer 2 switch work and how layer 3 or router is work, then we'll understand how packet will flow and how actually we will ensure the security on our network. That would better for us to understand how security works in a network. So uh, to understand that part, I just before I have to open first a whiteboard. So let me stop the presentation first. I think all of you guys are seeing the whiteboard, right, Ibrahim?
Yes, ma'am.
So are you seeing a whiteboard on screen?
Yes, yes, whiteboard visible now.
Okay, so before starting our session, to again open. Okay. So same. This is a switch. And behind that,
Nozul bhai,
yes,
we just see a black screen now.
that is okay.
Your whiteboard is not visible.
Ibrahim now.
It's coming. Just
Are seeing whiteboard or not?
no, not now. Yeah. It's asks double click to enter full screen mode, but the screen is black.
Okay, let me stop that part.
Try to again start. Then maybe.
Okay, sure. So now you're seeing presentation.
Yes, now it's okay.
Okay, now I just present opening the presentation. Okay, let draw that part in here. That would be better for us also. Okay, guys, sorry for interruption. So let's say this is our layer 2 switch, and behind that there is an host and there is a host. Let's say this is the host IP of this is 192.168.1.1, and this IP is 192.168.1.2, and the MAC address of this host is say A, and this is say BBP, and this is host PCA, and this is PC. So I think all of you guys remember how actually layer 2 switches work, right? So the when PCA wants to communicate with the PCB, what switch will do? Switch will do the switch will first, when the frame is coming to the switch, it will first verify the MAC address, right? That means the switch first check some of the Ethernet frame, and it makes sure that the frame that come in from, say, let's say this is uh, Ethernet ETH0 and this is ETH1. So let's say the PCA wants to communicate with the PC to someone raising hand. Is there any issue, Ibrahim?
No issue. I think sound is clear, but
Okay, guys, if you have any question on that part, I will give you.
Participant says write on whiteboard. You right now the PowerPoint presentation.
Okay, okay. I think I have to open another one. Okay. This is the IP and the MAC is BBB, and this is say PCB, and behind that this is PC1, IP is say 192.168.1.1, and the MAC address is A, and this is PCA, and this is layer 2 switch and 2 switch. Okay, so I think that now it's clear, right? So if PC1 wants to communicate with the PCB, so how actually say PC1 wants to communicate with the PCB, what switch will do? When packet come into this port, say this is the port 1 and this is the port 2. When a request come into the port 1, what switch will do? Switch will first check if the frame, check some of the frame, and it will make sure that frame would not corrupt, right, or altered. So if it is okay, then you check what is the destination MAC address of the frame, source and MAC. Then first he just, if the switch is first, oh sorry, so this is your MAC table. Getting some problem actually. Sorry guys, I'm Actually, I'm facing some issue on X. That's why. Okay, I think now it's okay. So this is a MAC table, and this is the port number, and this is the MAC. So when the switch first learned the frame, he just uh, added the MAC of the source, the PCA into the MAC table, right? So this is the first Ethernet one, say one port, and the MAC address of the PC is A, right? Then after that, the switch forward the Ethernet frame to the correct interface. If correct interface is what? If the MAC table has the destination MAC address interface knows about the destination MAC address interface, then it will forward the MAC address into the port 2. But if MAC address MAC table don't have that MAC address on his MAC table, what switch will do? Switch will flood the MAC, right? So say MAC ad switch know about the interface of the PCB, then he will just forward that packet on port 2, that is port 2, and that is port B. The MAC address is BB, right? So in these scenarios, the PCA communicated with the PCB. So there is three major things, right? The first, the switch will verify the checksum of the Ethernet frame to make sure it is corrupted or not, right? Then the switch receives an Ethernet frame and add the source MAC address into the MAC table, right? After that, in third stage, the switch will forward the frame to the correct interface. If it is knows about the destination MAC address. If not, the switch will forward the MAC address, right? So in this way, the layer 2 will work, right? So this is the common scenario we already know all or this, right? So let's see how actually or what happened on the layer 3, right? So say this is your say layer 3 switch, right? And this is your PC, and this is your PC, right? So say this is your PC AMAC or whatever it was, and this is the layer 3 switch I said, right? So there's something the IP address said on that interface, which actually layer 3 switch or router, right? So the IP of the PCA is say 192.168.1.1, and the gateway of the PC1 is here, that is say 1.254, and the other hand that is say 2.5254, and the IP address of the PCB is 2.1. So we have already know about the PCA, that is MAC address of the PCA is AAA, and the MAC address of the PCB is BBB. The IP address of the PCA is 1.1, 192.168.1.1, and the gateway of the PCA is 1.254, that is set on the layer 3 switch or router. And the PCB MAC address is BBB, and the IP address of the PCB is 2.1, and the gateway of the PCB is 2.254. So when PC1 wants to communicate with the PCB, how actually it works? So first, when it will check the the switch will verify the checksum first. It's look like the on layer 2. It will verify the checksum of the Ethernet frame to make sure it is not corrupted, right? Then the switch will verify the checksum of the IP packet. It's also same to check the packet is not corrupted or altered, whatever it is. Then the switch what will do, check the ARP table. See, there is the it's a layer 3 device, right? Then there is something called ARP. We know about the address resolution protocol, right? So actually ARP works for mapping MAC address to IP, right? So let's check the ARP table, see if there any layer 2 mapping for the PCB. If there is no mapping on that part, then he will send the ARP request, right? If the destination MAC address of the B, that is, the source address of the PCA on the MAC table, then he will added that MAC in the MAC table of the switch. So this is switch 1. So this is MAC added it on the switch 1 MAC table, right? And it also added in which way it's learning the MAC address of the PCA. Say this is the first Ethernet 0, then he will add the first Ethernet 0 and the MAC address is AAA, right? Then he will also check the destination MAC address. What is the destination MAC? That is the PCB, right? MAC address. And if that MAC on the MAC address belongs to the MAC address table of the switch 1, then he will forward it. If that not, then he will flood. So, but if you see there is something, the IP box subnet, right? So the destination MAC address change when layer 3 work, the destination MAC address will be changed with the MAC address of the first Ethernet 1, right? So there is a segment we know about the broadcast, right? So we know the in layer 2 switch, full layer 2 switch is one broadcast domain, right? But in layer 3 switch, in every port is under one broadcast. So this part is one broadcast and this part is one broadcast, right? So if you want to flood the MAC address with the broadcast, it would not be possible, right? Then what happened? He just trying to reach out the destination IP, right? Or check out the R20. So after that, he will check the TTL field. The IP packet is decreased. Fine is just changing the source MAC address. Earlier, the source MAC address was AAA, right? When it is coming into the switch, he would forward into the B with the change the source address of the first Ethernet 1. If the first Ethernet, say this is the DGT and this is the CCC, right? Then the source MAC address would be the DDD and the destination MAC address would be the DBB, right? Then switch what will do? Switch will decrease the TTL value of the packet, right? So, cause when is changing the interface, I mean changing the subnet, he will decrease the TTL value by 1, right? Then the Ethernet frame carrying the IP packet will send into the PC. So this is actually the way how the layer 2 switch works. So if we sum up of the scenario, what in first the check the ARP table, see if there is on layer 2 or layer 3 mapping for the PC. 2. If there is no mapping, the switch or the router will send ARP request. This is the step one. The step two, the destination MAC address changing from where to where. That is from AA to the address of the first Ethernet one, that is say DDD. Then you change the destination MAC address, right? So earlier when sending the request PCA, the destination MAC address was the gateway of his interface, right? That was the CCC. Then he will change into that part on the TBB when he is sending source address is source MAC address DDD and the destination MAC would be the DBD. The fourth stage is the TTL, decrease the TTL. When he's changing one interface to another, packet is forwarding one interface to another, he's just changing the TTL below of the IP header. So after that, the Ethernet frame carrying from one interface to another. This is how the layer 3 and the router work when sending a packet from one interface to another. So why actually? So there is lots of space here. So if you want check and ensure the security here, there is somewhere we can control here. So when looking at the multi-layers, there is a separation duties, right? We have to build a table of MAC address, fill in a routing table, ARP request, check an IP, packet match, etc. And also there is something ACL we will discuss later, that is the also part of this stage. Then after that, we can forward the IP packet from one host to another host. So when we are sending packet from one host to another host, the forwarding pattern is divided into the two plans, that is control plane and data plane. So to describe that part, I just describing this layer 2 and layer 3 working procedure here. So what is actually the control plane and what? So let's coming into our presentation. So there is actually the three plan. One is control plan, and data plan, and management plan. So what is control plan actually? The control plan is responsible for exchanging routing information using the routing protocols like REAP, escape, AJRP, and building routing table using that protocol, and also make the ARP table. So control actually this is the decision maker, how actually traffic will be forwarded on the router. That is responsible that part, right? The data plan is responsible for the actual forwarding of the IP packet. Make sense? So there is two things. First thing, the control plan is responsible for exchanging routing information. Right? And using the routing protocol, it make that decision and also build the routing table and ARP table, right? So that's the control plan. And the data plan is responsible for forwarding the packet. Actually the forward the packet. So when the routing table forwarding the packet, there is also something happen behind the scene, right? So it to visualize that part, we have to just understand another thing, that is the recursive routing will come into that part next. And another plan is management plan. That is actually for managing the infrastructure or managing the router switch or something like that. So there is actually three plans. One is control plan, data plan, and management plan. Make sense, guys? So when we are trying to secure something on network, then that's related to the control plan or data plan or management plan, right? So the routing table is not very suitable for fast forwarding, right? Because we have to deal with something else like recursive routing. So what actually the recursive routing is? Let's look example. Say this is router A and this router, say this is R1, R2, and R3. The IP just, okay, let me make it to 168, say 12.0/24, 1 and 2, that's a 12, and 192, 168, 23.0/24. Set this interface IP is 1, this interface IP is 2, this interface IP is 2, this interface IP is 3. And behind that, say there is a loopback. The IP address of the loopback is 3, 3, 3, and 3. That is the loopback interface IP. So when R1 wants to communicate with the loopback 3, how actually he'll communicate on R1? So then say we are using the static route to reach the 333, we have to place static route, right? Say the route, let's say I just write down the first command is IP route. All of you know that how to write down the static route. So IP route is the command and the destination, say this is the loopback interface IP, and the subnet mask of the loopback is 255 to 55 to 55, and the next hop of the say loopback interface is the IP of the R3 interface IP. So that is say 192.168.23.3, right? So when a router trying to reach 3.3, the static route for that on R1, that is 23.3, right? But to reach the 23.3, there would be another static route, right? So IP route 192.168.23.0, sorry, okay, to 55 to 55 to 55.0, and the next of that part is 192.168.12.2, right? So we if you want to reach the 3.3, the loopback interface of the R3, then we have to check out the two route on R1, right? First one, say, is there any route for 3.3 on R1? Yes, we have the route for R1, that is 3.3. And the next of the 3.3 is 23.3. That router will check is it connected interface, or it has any other route to reach the 23.3. So we have another route for to reach the 23.3, that is 12.2. So when you're trying to reach 3.3, we have to check out multiple route on router. So that's why we have to check out multiple route in R1. When router doing multiple lookup to reach a certain network, it's called recursive routing. Make sense, guys? When multiple lookup need to check to reach the certain network. It's called recursive routing. So router doing that recursive routing. That's why route the process of the forwarding packet not the faster, right? So that's why there is other plan is come up with that part. So we heard about the wire speed, right? So it's nothing but when the switch or router sending packet to the speed of the hardware, that's called actually the wire speed. So when we are trying to reach any packet, then how control plane and data plane work. So control plane, most of the IP packet can be forwarded by the data plane, but there is some special packets like with routing protocol, OSPF, EAJLP, URI. Also some packet that has the IP option on that in IP header, and also some packet that data plane cannot process that part. Then the control plane that packet will handle by control plane. So IP packet that are distant one of the IP address of the layer switch or layer C, that is also handled by control plane, right? So we already know information like MAC address, the routing table access is stored on the router and switch. When something about you first time here know about the ASIC, right? So if you are earlier not heard about that part, it's like magnetic storage, nothing but or the ASIC. What ASIC will do? ASIC will do the store the MAC information and the routing table, also the access list on the hardware level. The the table is stored in the CAM, that is we know about called that is the MAC table, right? So what MAC table do? MAC will just do the store the source MAC address, the interface where it is learned, and the Boolean reversion. Is there any Boolean reversion mapping on that part, right? Another thing that is come up with the ASIC, that is the TCAP, that is the ternary content addressable memory. So that what that will do? The actually the CAM table or the routing table what to see on the data plan or control plan, that is actually working on the switch software level, right? When ASICs come up with the switch or is come up with the SC, then the table or TCAM is what actually on the hardware level. So then actually the major portion of that part is to smooth or faster the packet forwarding. So that is another thing I just sharing the information, that is the high level information what the CAM table is storing, that is access list, say QS, quality of service information, and routing table, etc. So why it's called the TCAM? It's called TCAM because it has three different value, 0, 1, and X. That is another part. So when TCAM is processing the packets, is there is three processing method. One is processing switching, fast switching, and safe. We are not going that part here. So that is actually the major things on the control plan, data plan, and SD plan work. So, so if we see the table, how actually it's look like. Say this is your data. This is your actually the manage data plan. Say this is actually your data plan, right? When packet is coming to that part, is just forwarding that packet. One, this is the interface and this is the interface, right? When the data plan works, is just forwarding the packet. I already told when some packets, the special packets that not forwarding by the data plan, it goes into the control plan, right? So when control plan is so actually working the routing protocol like OSPF, AJLP, static route, and something like that. When OSPF work, it's also maintain something neighbor table link status IP routing table on that part. And the management part is to manage the devices, right? So it's also responsible to secure and ensure the management part. So the plan is plan operation is look like that tab. So when will try to ensure the protection of the management plan, where actually we'll do that. So the protection of the management plan is as security feature of Cisco IOS, right? So what the management plan protection is do that it's actually restrict the interface for the router packets come into the to the network devices or management protocol, and how actually restrict the network management protocol actually permit or deny, right? So management protocol that protection management plan protection is supported by some protocol that is you also seeing here, that is look like the HTTP, HTTPS, SSH, Telnet. So when actually we are trying to or reaching the router or switch using the management plan, and this is the protocol that we can use to protect. So if you check how actually the management plan protection work, so let's quickly take a take a lab. So for that first say, okay, I just stay using an emulator that is the PIB. So we already know about that. So say this is the router. If you say you want to protect some management traffic that is coming into the CSR router, the PC1, PC2 is the host. It's connected to via interface gig 0, gig 2, and gig 1. So before that, we have to set the IP of the PC1. So let's quickly. Okay. Let's check out the. Okay, before that, what I'll do. Actually, the focusing of this lab is to protect the management plan. So when we are trying to or reach the CSR router, configure the CSR router through Telnet, SSH, SNMP, HTTP, or HTTPS, how we will protect that protocol via management plan. That is actually our target. So say we'll set the IP address of the host PC1 is say 192.168 1.1, and the PC of the is 192.168.2.1, and the gigabit was .254 and also .254. So now coming back into our lab. It's already set 1.1, and the gateway of the PC1 is 1.254. Okay. And the PC. Okay, the IP of the PC is 2.2 and the gateway is 254, or the IP is already set on PC, right? Now we have to check the router. Let me first okay. So first check how many interfaces are there. So there is 4 interface on gigabit convert 0 by 0. So let first configure the interface IP, that is gig 0 by 1, interface gig 1, IP address is 192.168.2.254, right? So now shut. Then the interface gig 2, IP address 192.168.1.254. No shut. Show an interface gig 1. Okay. So if we go back into the PC1, that's already come up. So if you check the gateway of the PC1, say that is 192.168.1.254. That is okay. So it's already reachable, right? So what is our target? What actually we want to do? Say you want to telnet or SH into the router. To configure that part, say this is our router. Show run saying good line. So there is DTY. So you have to configure that part. Say line DTY 04 transport input SSH. Say we want enable the DTY terminal that is used to connect virtually to manage the router. So we're just allowing the SSH, not allowing the telnet or other things, right? So if we now trying to reach say 192.168 or 1.254, and we're trying to do the telnet, right? See, the network connection is refused, right? But what actually happening in route part, say if you wanna check the IP packets, say debug IP packet, that is the IP packet, and now we are trying to now see what actually I'm trying to say. The source address that is the source address on 254, that is using the FIB 1.1, So actually it would, okay, source, that is the source, that is the source, that is the source, right? So it's actually using the router. It's already forwarding the packet. The packet is coming into the router. So that means when any packet come into the router will process that packet, whether it would allowed or not. If any of the hosts is trying to attack or using that part, it can be possible, right? So if PC1 wants to perform a denial of service attack, it could be possible because we are not restricting the management protocol on the router. We just allowing the SSH on the router, right? Say show run. If we go into the PTY terminal, see transport protocol that we are allowing for input, that is SSH. Other we are not allowing, but we are trying to access through the telnet. That part also coming into the router. When any packet coming to the router will process that. When it's come with the huge volume of the packet, and in for DOS will come into tomorrow, that part. What is the DDoS? So router have to process that part also, right? So it's actually overloading for the router. And when huge packets come with that protocol, router have to process every packet, right? And after certain period, the router will corrupt, right? And it will the memory will be. So how actually will secure that management portion? So to ensure that part, what we have to do, we have to allow the interface where actually we just allow we just allowing the protocol or access that is coming to that interface, other interfaces will not accept it, right? So to configure that management plan protection, we have to go control plan host. Now we have to configure the management interface. That is actually the inbound, not the outbound. Nowadays, some of the routers come, not some of the, most of the router come up with the out of band interface that is actually used for management. But we are trying to configure management interface from the inbound interface that is actually used for data. So we are trying to allowing the interface that is come the gig to for management protocol, right? So management interface gig to allow, if we check which protocol, say if you want to SSH, right? So right, we just what we are trying to do here, we're just trying to do the only interface who is allowed for SSH protocol. None of the interface will allowing for that protocol for management, right? So if we check how management interface look like, to check the management look like, show management interface. See, the management is configured to gig 0/2. There no package coming with that protocol. So now if we check here, say 68 was the IP 1.254, right? And we are now trying to reach 254, right? So now check see, show management interface. See, the packet process, the three packet is processed for here, right? So in this way, we can protect our router in management layer, right? So there is some MRP restriction on the interface level, right? So there is lots of protocol. If you go back into the management part, say control plan host, management interface gig 1, and allow. If we check the protocol, which protocol we can use to protect, that is the HTTP, HTTPS, SNMP, SSH, and Telnet, right? So we can do that in that way we can communicate, right? So in this way we can protect our router or switch in management plan. So guys, hope you understand. If you have any question, you can raise your hand. Ibrahim, you there?
Yeah.
Oh, okay. Actually, we are on. We have already discussed the management plan, so we can take some question in this moment. So I'm giving one question answer, that what is the loopback IP and what is the main function of it. So loopback IP is nothing. It's a first. What is the loopback interface? Loopback interface is the virtual interface that is not the physical interface configured on router. Actually, it's a virtual interface, right? So if a router would not shut down, or we can, if we don't shut down the interface, the IP of the interface will lie, right? So that's why we use the loopback interface. There is a chance to shut down the interface if the physical connectivity is down, right? So if we use the loopback interface IP for any purpose, there it's possible to reach any of the router, we can reach the loopback interface IP, right? So is there any other question? I think you understand solution.
So one of participant press hand raise, Mr. Abdul Ahad. Please ask your question.
Yes, my question is that actually in case of management protocol, sir, I'm not clear about that, because actually we want to block another protocol like FTP, HTTPS in the gigabyte interface 2. Only allow SSS, only allowed telnet from PC1 to our router gigabyte interface 2, and default other protocol will block. Is it right?
Not actually that. Actually, what we are trying to do. So if we don't configure the management plan, what router do? He will accept all the connection that is coming into the PC1 or PC2, PC3, whatever is, right? So it will process all the packets. That is the protocol that we use for management, right? When we will want to block that portion, that the packet, the management protocol that would not come up with other interface, what we will configure on control plane. That means we are trying to configure, or we have configured the gig interface 2 for the management interface, right? So router will only accept the management protocol connection on gig interface 2, not from other interface. Make sense?
Yes.
Okay, Nazrul bhai, two questions more for from question answer box. Then we.
Okay. Why classless IP is used? That is another portion. How to configure the topologizer. So if like describe the class list. There is so in short, the class there is it in IPv4. There is we can got the IP is classless and classful. When the IP mask is default, that's called the classful. When same in classless, if you see in class A for short, say class A, starting from 0 to 126, right? So the default mask, say I am writing 11.0.0.0.0, right? The mask of this IP is what? That is 255.0.0.0. That means in one subnet to the power 24 host in one subnet, right? So if we use that network in any of this portion, we are same in here, we are using only two IP, right? So if we say configure classless IP in here, say 11.0.0. Say 1 or 11.0.0.2, rest of the IP will wastes, right? So to minimize the IP waste, we are configure classless IP. In short, how to configure if topologies? You have to deploy the EVMG first. There is you just search on the Google EVMG, then you will find how actually deploy, and you will find the images also there. I think Mr. Ajum, you will find your answer. Tambul Hassan BUPT. You allowed SSH for gig, but in PCU, so the router is not accessible through the SSH. Why? Good question. Is there any procedure seeing the port number? I just showing you the packet on the interface, right? That is coming, but we have to make sure the SSH also configured on the router, right? So we didn't configure the SSH on the router. That's why we are unable to access through the SSH. Make sense? Is there any possibility to change the port number of the protocol? I don't know the port number of the protocol like SSH. So by default, for the management plan, we cannot change the default port number, right? So because the interface we are actually securing the only for management, the interface only allowing the for management, right? So the for the management perspective, we cannot change the default port of the SSH and telnet. What is the process to find QMO PC1? Okay, if you need the QMO of the PC1, please ping me personally. Then I will provide you. And you also search on Google. There are lots. There is a lots of forum. You will find it over there. Okay. I think all of you guys understand how actually a management plan work. So, is there any other question? Okay. I think we don't have any other questions, so we can proceed our next part.
Apsara, have a question? So you can get more time after half an hour later, so you can ask them.
If you take the question quickly, then I can answer the question, or you can resume our lecture.
Apsara, your microphone is enabled. Okay, Nazul, we can.
Okay, okay. I have already I have already show you the how to configure the MPP configuration. So let's move on to our next topic, that is the control plane policy. So on our router, actually, or layer 3 switch, what we can do, we can use access list or firewall to permit or deny, right? So we'll check out what is the ACL on its later side. Also, what we can do, we can polish it to rate limit the router, right? I'm just talking about the control plan. What if we want to police traffic that is destined to the router? There are quite some protocols that produce the packet to the router has to process, like OSPF, PAGLP, BGP, and also on layer 3 switch, there are other protocol like HSR, RP, DRRP, and GLBP, and also the management protocol like SNMP, SH, and various. So the router process and inspect the packet. These protocol and generated on the control plane, right? When when a route processor receives many packets, so it's possible that it can keep track of the packet, right? And what happen if the router or the, let's say, switch processing a packet that is coming into the control plane? It's actually use a framework to permit or deny the traffic when its route processor working on that packet. So that the protection of this control plane is for con policing and control the control plane, routing protocols or packets, whatever we can say. So when we are trying to reach say, any of the routing protocols, say OSPF of EAGRP, right? So we have to protect that part also, right? So to protect that part, we don't need to apply the ACL individual apply on the interface. Obviously, some of the router or switch have that portion, but most of the times we don't need to apply that ACL on a specific interface. So it's actually protect the DOS attack targeting on the network infrastructure. So why you actually use the control plane policy? It's actually used for ensure the security and availability of the network devices. So how actually we can protect our network infrastructure? So to protect our network, so we can policy for the control plane. So if we check out the example, then we'll understand it. Say what we are trying to do. We are trying to apply policy for the ICMP, Telnet, OSPF, and HSRP. To applying the policy, we have to first create a ACL. So that is the first thing. So step one, we have to configure the access control list. So to configure the access control list, that is the process. The IP access list, we are using the access list. We are coming to the access list later. Just remember, this is the way to configure the extended access list or named access list, what we can say. We are this access list used for ICMP. That's why we're naming it ICMP. The permit ICMP is the protocol, any source, any destination. And the access list for the telnet, the TCP is the port, any to any means source, any destination. And EQ means equal to, and the port is 20. Actually, this ACL is configuring for matching the 23 port that is coming into any of the source and going to any of the destination. That we know the port of the telnet is 23. That's why we are using EQ operator. EQ operator used to match the port number. And when we are using the OSPF, the permit, the OSPF is the protocol and any source, any destination. When we are trying to match the HSRP protocol, the HSRP use the UDP and any host. And now in here we are matching the host, that is the destination host, the multicast address, that is 2240.1.2, and equal to port number is 1985, that is used for HSRP. So in here you just saying we are configuring 4 access list for control plan policy. After that, what we have to do, we have to configure the class map. Let's see on our next slide. The class map, also we are naming the same. The class map is ICMP. You see, earlier what was the name of the ACL? That is the ICMP. So we are matching the access group name is ICMP. And for telnet, we are also using the telnet name. For the class map OSPF, we are naming also OSPF, and the ACL name was the OSPF. And the HSRP, we are also naming the HSRP class map, the HSRP, and the name of the ACL was HSRP. So in first stage, we have configured ACL. Second stage, we are configuring class map. Next stage, we have to configure the policy map. So let's see how actually policy map is configured. So this is the policy map. We are mapping the configuring the policy map, that is naming COPP. That is the main. Under that policy map, we are calling the class map, that is ICMP, and that is actually the main part of the control plan policy. Here you see policy 8000, that means 8000 bits we are allowing, and confirm action transmit X. Confirm action transmit, that means the packet will transmit. If the packets crossing the limit, then what will happen? And exit action also here, this time the transmit. Why we are actually exit action plan configuring the transmit? So we are say add the policy for 8000 TPS, right? And the confirm action and the exit action are both set to the transmit. This policy will never drop anything, but there is a good reason I configure the exit action transmit. When you configure the control plan policy for the first time, you don't know how much packet you receive for each protocol. You don't know. There is a risk that you deny legitimate traffic. Like, so when your traffic is coming, when is traffic, the packet is exceeding your limit, then if you exit action is dropped, then it will drop all the packets. So that's why first time we will configure the exit action is transmit. Then we know about how many packets is coming in that way. After that, we can polish our policy in policy map. Say right now we are using in 8000. If we see the packet is coming more than that, then we can modify that part also, right? So that's why first time when we will configure the policy map for the control plan policy, we just transmit exit action. After that, we can modify that part, right? So it's best to permit everything first time. Once you know how much packet are exceeding, change the value and set the exit action drop, right? So when you seeing the packet is more than 8000, say it's 10,000 bits for the ICMP. Then you can modify that part, and the action plan will be then dropped, right? So in here, what we are trying to do, we are trying to do first matching the class map. Then we have polished the ICMP packet, that is 8,000, and the confirm action is transmit whenever it is goes 8,000, and also if it is exceed the polish, then also transmit. If you get the actual packet size, then we will mention in here, right? So in that way, we can configure the telnet polish, also the OSPF and HSLP polish also, right? So in first stage, what we have done ACL. Second stage, what we have done, that is the class map. And third stage, we have configured the policy map, right? After that, we have to apply that policy map into the control plan, where if you now see how actually look like. Okay, so if you see in the control plan host, so sorry, not control plan host. See, if you go into the control plan, there is another thing, that is service policy, right? So we can configure the service policy under the control plan. So in here, we will apply that part. So if you configure this part, say, okay, let me configure this on. Okay. To configure. Okay, let's say we are just configuring for ICMP and telnet in our router. Then what we do, we just paste that part, right? So if we see show IP access list, see there is two access to configured, one for the ICMP, another for telnet, right? So after that, we have to configure the class map. So after that, we have to configure the policy map for telnet and ICMP, right? So guys, I just copy and paste to save our time because there is a time limitation. Actually, if we want to cover most of the things, then sometimes we have to copy and paste the configuration. So it's nothing. I already described what I am doing here. Okay, so we have already configured the policy map, right? So now we have to configure a control plan, configure the control plan, right? So to configure the control plan, what we'll do? So to configure the control plan policy, you have to go under the control plan, then the service policy. What will be the service policy direction? That is the same. There is the input and output. Assigning policy map to the input of an interface or output. So we are trying to do our on input interface, right? So what is input? That is the request coming into the router, not going from router to outside. So the request is coming into the router. That's why we'll use input direction and the name of the policy, that is COP, right? So we already enabled that part. Now, if you go check out the policy control map, see show policy map control plan. See the what is the service bus, that is COP, and the class map ICMP, and the telnet, right? So here you see we are just configured the policy map. So if we now ping from PC1 to host 254, 1.254, right? So how it's look like. Show policy map control plan, right? See, we just received the 4 packet, right? And the size of the 4 packet is 240 bytes. But we have configured the committed information rate is 8,000. Yes, right? So that we have already received 240, right? So this is this is how we can actually configure the policy map to control our control plan or to secure our control plan. So this is all about the control plan policy. You can configure or limit your policy to avoid or DDoS attack or any of your devices, right? Or ensure the security of your infrastructure. So this is how we can configure. So how actually look like the view of the control plan policy? It's say incoming packet is coming into the router on the in interface. Then the processor what will do? If the packet is I've already described the query speed, right? Or find the packet is forwarding based on the hardware speed or safe, then it's use the safe packet, right? Then it has some routing information like ACLE or RPA or net. It's already maintaining that table and the packet forwarding based on that table into the outside. If that is not the packet cannot forward it through this table, then it forward in the control plane. To avoid to minimize the attack of the control plane, you can configure the control policy here. Then the input is the policy. The manage where in control plane we can secure the management plan, SNMP, Telnet, ICMP, ABDC, sorting, and all those things, right? And when we are we'll try to polish the outside packet also, then we'll set on outside direction of the policy map. So this is actually the process or flow how actually the control policy work. So first packet come into that way, and if the table that is maintaining on the SAFE or ASIC, that will forward based on that. If that not possible on that through the data plane, then it will forward into the control plane. And if we want to secure that control plane, then we can ensure we can define in here that is the input, right? The packet is coming into the control plane. So if you want also limit the output plan also, then we can define here for out, so inside or outside. So in how to configure the control plan policy, we are already know that, right, guys? So is there any question, guys? Just quickly, I can take few questions here. Guys, do you have any question? Which platform design network simulation used the GNS packet tracer Islam? I am to simulate that I am doing the topology on GNS3, not GNS3, EVE-NG Pro. So it's EVE-NG. Is it possible to DDoS can manage to take your network security? Rex, is it possible to DDoS can manage to break your network security? Actually, we are trying to secure our network from DDoS, but there also a chance because we are limiting the policing, but have some limits, right? Say 8,000 or 10,000, right? So when you're setting that CIR, that means committed information break, that means the interface will pass 8,000 bytes on coming into the control plane, right? But if a DDoS happen, it also possible the network break the network security, right? But we are limiting that part. We cannot break, we cannot control DDoS, right? So we just limit the or ensure the network security from DDoS. So actually, it's a broad topic. What is DOS and what is DDoS? We'll check out the that part on the next day. Is there any problem to use the packet tracer? No problem. You can use that packet tracer to simulate the topology. You can use packet tracer. You can use GNS3, any of them. I think, guys, you understand why actually we are limiting. Okay. So now coming into the access list. What is access list? Why actually need the access list? We already know about that. So we are not in the perfect world, right, guys? So if we are in the perfect world, then we can trust anybody. Like then anybody cannot any mistake, and all are working perfectly in perfect world, right? But in real world, it's not look like that, right? So in there some we can if say there is no attacker or this, but we can have some mistake, right? We can It can happen in our networks, right, or real life. So in access list, work on layer 3 and transport layer 4 layer 4. It can be used for two different major things. First thing is for filtering. First thing for filtering, and another thing for classification. So SCL access list actually is the rules which will allow or deny your specific traffic based on layer 3 and layer 4 information, right? So it's another it's called the packet filtering for, but its major task is filtering and the classification. So what is the filtering? Filtering is nothing, it's just permit or deny traffic reaching certain part of your network. Without filtering, what the traffic will do? It can move anywhere, anywhere of your network, right? So if you see an example, like look like, say this is your topology. Under that there is another router, under that another router, under that there is a switch, under that there is a switch, under that there is a switch. All of the router is connected, and this is your router, right? So say if you are trying to block some in here that is not going to Earth's internet or not going to your, say this is R1, this is R2, this is R3, this is R4. R4. So if you want to block, say traffic from here to here, or if you want to block traffic from here to here, then we have to configure the access control list. That when we are trying to filter something here or blocking here, that's called filtering, nothing else. And what's the classification? The classification does not block anything. It's just used to select the traffic. What is that? What that is, it's look like same. This is your router, and also this is your router. Say it has to, like, one is 192.168.2.0/24, and another one is 192.168.1.0/24, and this is 192.168.3.0/24, and some subnet IP or 10.0.0.0/13 here. So when you're trying to marking something, say from 192.168.3.0 to 2.0, sorry, 3.0 to 2.0, you are selecting from that part to that part, then we have to classification, right? So it's actually used when we are use the VPN or encrypted some traffic, say from 3 network to 2 network or 3 network to 1 network. So we are not encrypting all the traffic from 3 to 2 or 1. We are just we want to encrypt from, say, 192.168.3.0 0 network to 192.168.2.0 network. Then we have to select that traffic, right? So the way of the selecting the traffic is called the classification in ACL, right? Then the another thing come into the picture, in which bound, in which way, in which direction will classify or filter. So to understand that part, we're going next slide. We have to go next slide. Save. The way of the direction is two. One is inbound and outbound, but it can be any of the interface. Say this is another interface, fast Ethernet 0x1. So what we can do, we can apply the ACL or classification, or not a classification, we can apply the ACL any of the interface in two bound. One is inbound and one is outbound. Say if you want to block something, say this is your router. So if you want to block, say this is 192.168.1.0 and this is 192.168.2.0. So in router 2, what you will do if you want to block something like say 192.168 4.0 to 1.0 network. So you will block, you can block in any of the direction. If we set the rules on in that interface, that would be the inbound, right? The packet is coming from 4 network to your router and will go into the 1 network. If you set the rules in here, then it would be the outbound, right? So the thing is, when traffic is going from router to outside, that would be the outbound. And when traffic is coming into the router, then we will use the inbound. Make sense, guys? So to apply the ACL, we have to select the direction. For selecting the direction, we can use inbound and outbound on any of the interface. That is the procedure to apply the ACL. So there is lots of ACL. We will know about that. The major thing that we have to know, the standard and extended ACL. Standard, find the number standard ACL. Why will standard? Why will use standard? Will coming into that part next later side. But how will identify the standard access? Points the number is in between 1 to 99 to 1300 to 3.9. That is standard access list. And extended access list, when the number is in between 100 to 199 and 2000 to 26.9. And there is another name called the name access list that's also use the, that can be also use a standard and access extended access control list. Also there is something called the time based access control list to limit the time when oh guys, just sorry. So when we have to limit the time, say we want to block something from 9 a.m. to 5 p.m., then we have to filter based on the time. Then we will use the time-based access control list. Another thing, the dynamic access control list used when we will authorize based on the username, and the prospect of that part will coming the next part on later side. So another thing, how actually the ACL will flow. The ACL traffic flow when the packet is coming into a router. The same packet is coming into of the router, then what router will do, he'll check the routing table, see if there is any route for the packet in the routing table. If there is a routing on that part, uh, on the routing table, you will forward the packet on the interface. If there is no route on the routing table for the destination host, then it will deny, right? So on top, if we go into the destination interface, you will found the ACL on that interface, right? Then he will check whether the ACL statement is permit or deny. If the ACL statement is permit for the direction from source to destination, then he will allow the packet from the packet and send to the destination interface. If it would not permit the ACL, then it will drop or deny. So this is actually the traffic flow, how it's ACL is work. So first he will check the routing table. Then if we found the routing entry on the routing table, then he will choose the interface of the destination interface. In destination interface, he will, if there is an ACL, he will check the ACL entry. If ACL statement found, then he will check it is permit or deny. If it is permit, then it will forward the packet. If not permit, then deny. If ACL is not permit, there is no ACL on the interface, then we'll forward the packet. So in what is the standard access list? So in standard access list, we can actually define the source IP address, only the source IP address. We cannot define the destination IP address. We cannot define the protocol. We cannot define the port. So standard access list used when we can only use the source IP address. Like we want to block from one source block, then we can permit or deny based on the standard access list. How actually we can define the standard access list? The access list is the formula, then the ID. ID, what will be the ID? ID, we already know the 1 to 99 and 1300 to 1399. If we use the 1399, then router will consider it's a standard access control list. Then action can it can be permit or deny. Then the source IP, in which source IP we are going to permit or deny. Then we have to define the source IP and the wildcard mask, source wildcard mask. What is the wildcard mask? It is the opposite of subnet mask. Same, your subnet mask of your source is 255.255.255.0. Then the opposite of the wild is say then 0, 0, 0, 255, or what you can say 255, 255, 255, sorry, say 255, 255, 255, and 255, and the world subnet mask of your host is 255, 255, 0, and we'll found the world mask is 0.0.255. So this is the wildcard mask. So in this way, we can define the standard access list and what is the extended access control list. So access control list used for define when we are trying to permit or deny based on source IP, destination IP source, or destination port, right? So it's actually in extended access list, we can define the many of the things, right? So how actually you can configure this extended access control list? Same thing, first access control list, then the number or ID, the ID based on the extended access control list number. So if we use the 100 to 199, then router will consider it is a extended access control list. Then the action already said it can be permit or deny. then the protocol can be TCP, UDP, IP, right? So we can define the protocol here. Say we are trying to match the FTP protocol that is originating 10.10.10 to 30.21. So what we are trying to do here, we are denaming request from 192.168.10.10 to 30.22. In here, you see the wildcard mask is 0.0.0.0. What does it mean? It means we are only allowing the single host. When we will consider the single host, what will be the subnet mask? The subnet mask will be the /32, right? Then the opposite of the subnet mask, you will found the wildcard mask is 0.0.0.0, right? So in here, what we are trying to do, the protocol for the FTP, the protocol is TCP, and the source IP is 10.10, and the destination IP is 30.21. What we are matching using the operator, the EQ is the operator to matching the port, that is 21. So this is actually denying the 10.10 host to 30.21 or FTP request, right? So in this way, we can configure any or matching any of the rules or statement for allowing or denying for our network, right? So actually extended access list, we can consider many of the things. We can match the protocol, we can match the source IP, we can match the destination IP, we can match the source protocol with the source port, we can match the destination port, lots of things, right? So guys, I think all of you understand when we have to use the standard access control list, when we have to configure the extended access control list. Time based, I already defined when we have to manage. Say in now, say you are working off your office, say your administrator said you have to block the Facebook from 9 to 5 p.m. Then how you will configure that part? So based on that, then you have to configure the access list denying using the extended access list. You have to deny the Facebook destination Facebook host, right? So let's take example what it can be. Say we can configure the IP access list. Say we are configuring name extended named ACL. So then I'm naming that Facebook. Then what will be the statement we are denying, right? The statement will be the deny. The protocol will be the TCP, and the host, say we are trying to block from say 192.168.1 say 10.0 network, and the wildcard mask would be the 0.0.255. Let's say from 10 network to say let's say the Facebook server IP is 4.4.4.4, and sorry, there is something else. The host, say the host is 4.4.4.4 and equal to 40 is 80. So this is actually the extended ACL, right? We have already learned about that. We just rename the TCP from 10.192.168.10.0 network to 4.4.4 network, right? If it is matched with the 80 port, that means in 4.4.4 host, we are denying the traffic from 10 network. Then where actually will define the time? After that, we have to define the time here. So the command is time range. So time range, then it's named. Say if you define the time range, say x, y, z. That in time range, we have to define the period of times where actually we want to block the Facebook or host, right? So this is in this way we can define the time based ratio. So there is something need to define on the time based ratio. First, define the time base. So first define the time base already defined here. First, we have to define the time base in which can define how actually the time will say how actually a time base will configure say time range. I have already XYZ defined on ACL, right? So XYZ I'm naming, and periodic is the keyword or absolute. So I'm periodic. It can be daily, it can be weekdays, it can be weekend, or I can define only for Sunday or Monday or any of the day of the weeks. So say I can I want only weekdays and the time. After that we have to define the time from 09 to 1700. In this way we can define the time range. Then this time range we will apply on the ACL. In this way we can apply the time based ACL, or you can configure the time based ACL. And after that the ACL will be applied on the interface. And also we can define the time based ACL on virtual interface, right? That is line VTY. So where actually the time-based ACL, the time-based access list are type of access lists which allow network access on the basis of the time period, right? Make sense, guys? So already know about the named access control list. When we are mentioning the name on standard or extended access control list, then it's called the name access control list. So from iOS version 11.2 to later version, we can configure the name based ACL. So why actually come the name based ACL? The major limitation of the numbered access control, that is standard. If we use the standard and access control list, there is the number, right? So say the number of the ACL standard access is 1 to 99 and 1300 to 1999, right? So there is the limitation of the number. So if instead of the number, if we use the name, so there is no limitation of the name, right? So that's why you use the name access control list. So dynamic access control list. What is dynamic access control list and where actually is the dynamic access control list actually also called as a lock and key access control list. It's actually filter based on dynamic ACL. So what is dynamic ACL? Say you are trying to blocking somewhere else. Say this is your network. This is your network, right? So from outside, you are applying ACL. Say is your host. This is your host. You are just allowing this from this host, this IP say 1.1.1.100. So you are just allowing from this host to your network access, right? While this host or this person is moving this to this, say from here to here, it will automatically deny, right? So in ACL, in a normal ACL, or it can be standard or extended dynamic, whatever it is we can if we change the location, if we change the IP, then we have to change the ACL also, right? So there is that is the nightmare of any of the network administrator, right? So he has had to change ACL according to whenever any of the host of any of the person moving any of the location, right? So to avoid this, uh, the Cisco come up with the dynamic access control list. So where it actually define the ACL based on the user access policy. That means find a user first uh, accessing or authorized based on their user and password. That is first he will authorize using their username and password. After that, it would automatically telnet on that router or the device. Then the based on the ACL, it would automatically create a dynamic ACL, right? So that is called actually the dynamic access control list, and it's another name called lock and key. Hope you understand, guys. So I think we are uh, just end of the lecture, sending up the logic. So it's all about today's lecture. If guys, hope you understand what is the ACL, how actually configure, and what is the plan back, different type of plans, how actually protect management plan, control plan, guys. So if you have any question, you can raise your hand or you can write down your question and answer section.